Hi everyone, in this video, I'll be showing you how to draw the schematic for your project and simulate it using Proteus. The first thing you have to do is to click on File and then select New Project. And then there will be a dialog box that will open. Let us call it ATS or Automatic Transfer Switch Final. After that, you tick this box to make it a new project and don't select from development board, followed by clicking next, and then you need to select the template for creating your schematic from this option. So I'll be selecting the A4 in landscape mode. After that, I'll click on next. Now, if you want to use any specific microcontroller and you want to compile your code in Proteus, you can choose on create firmware project. But if you don't want to, you can select no firmware project. My project is a firmware project, but I want to do everything by myself. So I'll select no firmware project. After that, I'll click on next. Now all the settings are ready. All I have to do is to click on finish, and then I'll have a blank interface like this. When you look on your left, the main controls for Proteus are here. You can use this for selection. You can use this for selecting components into your screen. You can have this for the terminals mode. And then we have the virtual instruments over here. And then we also have generator mode over here. These tools down here are just for drawing geometric shapes in the Proteus interface. So let us begin to add parts to our schematic. The first part I'll add is the microcontroller. So I'll come here, click on P, and then a dialog box will open, and then I'll type ATmega 328 into the dialog box. So I see what I am looking for. You can change the package for the microcontroller you want to use using this dialog box if you want to make a PCB for your schematic right here in Proteus. So I'll be selecting the DIL28 and then I'll press on OK. So I'm going to place it somewhere in the middle of my project like this. Now the next thing I want to place is my virtual terminal. I'll be using that to show you what is happening in my circuit as a debugger. So I'll come here to instruments mode and then I'll select virtual terminal from these options. If you need an oscilloscope, you can find one here. If you need a logic analyzer, you can get one here as well. If you want to have a counter, you can also use that as well. And then we have the SPI debugger, I2C debugger. We have the signal generator, pattern generator, and then you can also get your multimeters over here as well as your watt meter. So I'll choose my virtual terminal and then I'll click where I want to place it in the schematic and then I'll place my virtual terminal over there. So the next thing I want to place is the LEDs. So I'll go back here to component mode and then I'll press on P followed by typing animated LED into the search box. So I'll choose the first color to be blue and then I'll click anywhere, the place I want to place it in my circuit, press on plus or minus on my keyboard, and then I'll place my first LED, which is the blue one, and then I'll press on P once more, and then I'll type animated LED once again, and then I'll choose the next color to be color green, and then I'll place it in my schematic, go back there again, repeat animated LED, and then I'll choose the next color I like, which is purple, and then I'll press on OK, and then I'll place it where I want it to be in my schematic, followed by the last LED, which is, so I'll choose color yellow, and then I'll press on OK, and then I'll place it here. The next two things I'll place are my push buttons. The one for the automatic mode, and then the one for switching between the grid and then the solar energy sources. So I'll press on P once more, and then I'll type in button, and then I'll select this active SPST push button, and then I'll place two of them in my schematic. Good. The next thing I'll place are current limiting resistors for these LEDs. So I'll press once again on P and then type resistor, and then I'll select the default that is selected, and then I'll place them as close as possible to the LEDs that they will be limit the current to. I'll be using internal pull-up resistors for this push button, so I wouldn't need any resistors for this. The next thing I like to do is to connect these ones before I move to the next stage. So all I have to do is I'll be connecting the RXD of the microcontroller to the TXD of the virtual terminal, as well as the RXD of the virtual terminal to the TXD of my microcontroller. After that, I'll connect this first LED to the first resistor, and then I'll connect this resistor to the LED. I'll connect the next microcontroller pin, which is PD2, to the next resistor, followed by the resistor to the LED in that order. I'm now connecting the last LED to the resistor, and then I'll create a big ground line over here like this to the push button. Connect this one as well to the push button, and then I'll connect this push button to PD6, and then I'll connect the last push button to PD7. Now let me connect the input of the solar energy source and then the input of the grid energy source. So to do that, I'll click on P once more, and then I'll use a logic state. The logic state can help you toggle between high and low. So I'll select this one, the active logic state, which is the latched action type. There's the momentary type as well. So I'll press on OK, and then I'll place them close to port B1 and then port B2. So I'll connect this one to port B1, this one to port B2. The next thing I'll be doing is to connect my relays. But since I'll be using my relays to control an inductive load, I need to opto isolate the relays from the microcontroller. So to do that, I'll be using opto isolators. So I'll be placing my two relays first. After that, I'll bring in the opto isolators, and then I'll show you how to connect them in Proteus. So I'll type in animated relay, and then I'll choose the single load side type. We have the two poles type as well. I'll choose the single pole type, and then I'll place the first one over here, and then I'll place the second one over here, like that. Now, I need to look for the opto isolators. So I'll come here, I'll select P, and then I'll type in 817. All right, so a lot of things come in. The part I'm looking for is PC817. So I'll select this type, and then I'll place it somewhere down here, like this. And I'll place this one also down here, like that. When I am done, I'll run you through the explanation of the circuit for the Opto Isolator. Now I need to place resistors and then some transistors to drive the relays. So I'll click once again on P, and then I'll select BC547 in my path selection menu, and then I'll place them somewhere around here. The first one goes here, second one goes here. And then I now need to put resistors on some inputs. So I'll come here and then select the resistor I had previously used, and then I'll put one on the base of this transistor, put another on the base of this transistor, and then I'll be putting one on the point where I'll be connecting my relay from, and then I'll put another one for the second relay. I'll be needing some resistors for the Opto Isolator as well. So I'll put this one here like this, and then I'll put this one here as well like that. So the next thing I'll do is to connect all of this. So I'll connect the first relay to PC0, and then I'll connect the second relay to PC1. After that, I will link this relay to this Opto Isolator here like this. And then I'll link this one as well to the next Opto Isolator like that. Then the next thing I'll do is to ground these two Opto Isolators. So I'll click here like this, and then after that, I'll connect all of this together. And then I'll go to terminals mode, and then I'll select ground, and then I'll place my ground somewhere around here, and then I'll connect all of these lines to the ground. I will then connect this resistor to the base of the transistor, and then connect this one as well to the base of this transistor. And then what I'll do next is I'll connect the collector of this transistor to this relay, the collector of this one as well to this part of the relay, and then I'll join this guy and this guy together, and then I'll go back to terminals mode, and then I'll select power, and then I'll connect this side to my power. I'll be changing this to plus 12 volts because these relays are 12-volt relays. So I'll click on plus followed by 12V, and then I'll press on OK, and then I'll close. The next thing I'll do is to connect these two emitters to ground. The next thing I will do is to connect the input of these transistors to the output of the Opto Isolator and wire up these resistors to the Opto Isolator. So I'll connect from this resistor to the collector of the Opto Isolator, and then I'll connect from this resistor to the collector of the Opto Isolator. After that, I'll connect the emitter of this one here to the input resistor of the first transistor, and then I'll connect from the emitter of this one to the input resistor of the next transistor. After that, I'll go back to the power rail and then connect the power pin, which is the 5 volt or VCC, to these two resistors here, like this, and then like that. And then I'll connect this one to the power, this one to the power as well. The next thing I'll do is the power supply. It is based on the LM7805 voltage regulator. So I'll click here and then come back to components mode, and then I'll click on P, and then I'll type in 7805. And then I'll select this 5 volt fixed 1 amp voltage regulator, and then I'll place it somewhere over here like this. And then I'll need two capacitors, one for the decoupling and then one for the input. So I'll type in 100 UF, and then I'll select any random value that is above 16 volts. And then I'll press on OK, and I'll put this one here, rotate it using the plus button, and I'll place another one here. After that, I'll look for 100 NF capacitor, also 16 volts, and then I'll place the two of them at the output of my voltage regulator. I'll then wire the voltage regulator up like I am doing right now, and then so I'll go back to the power rail, look for ground, and then connect my ground right here. And I'll connect it to the ground rail over here. And then I'll go to generator mode and then look for this DC generator. And then I'll put this generator as my voltage source at the input of my regulator. I'll double click on the regulator and change the voltage output to 12 volts. And then I'll now go into instrument mode, look for a DC voltmeter, and then measure what is at the input, and then measure what is also coming from the output. So I'll connect the voltage meters like this, and then like that. And then from here, like this. Like this. Now, the next thing I'll do is to change the values of the components I have used. You can see here I have 10K resistors, etc. So this is not the right value for it. I forgot to link this side to ground. So this value, I think I'll prefer to use a 100 ohm resistor because it works better. So I'll double click, and then I'll change all of this to 100 ohms for all the resistors connecting to LEDs. Now this one as well, I'll change them to 100 ohms, and then I'll change this as well to 100 ohms. Now let me explain this part of the circuit. What is happening here is simple. If I have a 5-volt output from the microcontroller, I don't want the 5 volts to interact with the coils of this relay. Neither do I want these relays to interact with the coils of the contactors. So to do that, I am isolating this part of the circuit using light. So what happens is if I'm able to turn these LEDs inside these opto isolators on, this transistor will automatically turn on to drive the rest of the process. So I have this resistor here limiting the current into this LED here, and then I ground it. So it's just similar to what I have done here. So once there's a high on the input of these pins, the LEDs here will light on, and then this will in turn turn these transistors on to drive the next process which is involved over here. So I'll change this value as well to, let's say, 470 ohms. And then I'll change this as well to 470 ohms. And then I'll change this ones to 1K. And then I'll change this one as well to 1K. So I'm reviewing the circuit to see that all my values are accurate. And then I'll change this one to VCC, which is here, which is my 5 volts. And then I'll change this supply output as well to VCC. Now I need to name some objects on this one. The first thing I'll name is this relays. So I'll call this relay the grid relay, and then I'll call this relay the solar relay. And then I'll call this push button manual, auto, manual, because you can use it to toggle between automatic and manual mode. And then I'll call this push button grid or solar. So grid / solar. So in effect, if the system is in automatic mode, it will decide everything by itself. And if it is in manual mode, you can press this button to switch between grid or the solar. And then I'll call this input, which is representing the grid input, as grid input. And then I'll call this one the solar input. Now we are left with the LEDs to name. So I'll call this LED auto LED, and then I'll call this LED manual LED. And then I'll call this LED grid LED, and then I'll call this one solar LED. Good. So the next thing we have to do is to simulate it. Now, we need to write a software for this microcontroller. I have already pre-written the software, and all I'll be doing is to load the hex files. So my goal is to simulate this and then add the files for you to be able to do it by yourselves. So I'll right-click on this microcontroller, and then I'll click on Edit Properties, and then I'll go through these settings over here and change them to what I want it to be like. So the first thing I'll do is, where is my program file or my software that I have written? When you are done writing your code for every microcontroller, the compiler either generates a binary file or a hex file for you. So I'm going to load a hex file into this microcontroller to be the software for it. I have already written that, and I'm now just coming to locate where I placed it and then put it into the microcontroller. Good. So the code is right here. I'll choose this. Now, these settings here are called the fuse bits. We need to modify them before the microcontroller can work. The first fuse bit here is called clock division by 8. This one divides the 16 megahertz clock signal by 8 to 2 megahertz. We don't want to program that, so I'll click on unprogrammed. We want it to work at 16 megahertz. And then clock out, also unprogrammed. Do you want to disable the reset signal? No, unprogrammed. Do you want to enable watchdog timer? No. Do you want to have some boot sectors? No. Now, what are our clock source fuses? That's what is the frequency we are going to use to drive the microcontroller. So I'm going to choose external crystal, which is a full swing one, like this. And then do I want a bootloader? No. What are my startup fuses? That's how long should the microcontroller take to start on? I'll choose 1. You can refer to the data sheet of the microcontroller for more information on that. And then I'll change the clock frequency to 16 megahertz. And then I make sure that it is not excluded from the simulation. And it is also not excluded from the PCB layout. After that, I'll press on enter. Let us now simulate our circuit. So once again, I'll be changing these inputs here. I'll be changing from 0 to 1, 1 to 0 to represent whatever power source is available. And then we are going to be seeing some output messages coming from here. Take this one to be your serial monitor. And we are going to have the LEDs also work in real time. And I'm going to show you how to modify the settings of the microcontroller using these push buttons. I will also take you through what happens at the power supply. So to start, you click on this play button. And then when you click on the play button, the first thing we notice here is the input of the power supply is 12 volts and the output is 5 volts, which is exactly what we want. Now, you notice that the grid input is at 0 and then the solar input is also at 0. And we can see clearly that the system is in automatic mode. The manual mode light flashes because the system doesn't know how to react. In this particular mode, I'm expecting that since the solar is off and the grid is off, the system is also off. But because we are simulating it, this is one of the scenarios to show you that our system is working. Let me now do the first change. Let me push this a little to this side so you can see what is going to be happening to the relays. So I'll change this to grid input being available. And then when grid input is available, you notice that it is still in automatic mode. But since there is no solar, it has chosen the grid as its priority power source. And then you notice that the grid relay is actually on. When the solar and the grid becomes available, look what will happen to this relay. It has moved to the on position now. The grid relay has now gone off, and the output on our debugging interface is showing that it has selected solar with priority. That is, the grid is available, the solar is available, but it has prioritized the solar. Let me now turn the grid off, and then let's see what will happen. So it is still in automatic mode, and it has selected automatic mode solar because only the solar is available at the moment. Let me turn both the grid and the solar on, and then I'll show you what is happening over here as well. So the system is in automatic mode. Solar mode is also on because the solar source has been selected. Let me now toggle between automatic and manual mode. So I'll press on this button, and then I'll keep my hand on it till the LED switches to manual mode. And then you notice that it is in what? Manual mode, and then it has selected solar manually. So I click on this button, I keep my hand on it for some brief period. You notice the purple light comes on to tell you that the grid is supposed to be on. So it has selected the grid by itself now. I don't know why it is toggling between the grid and then the solar, but I'll look at my code and then see why that is happening. So this is a basic simulation of the circuit. I have used the virtual terminal. I have used LEDs, different colors. I've used push buttons. I have used an opto isolator. I've used a voltage regulator. And I have also used relays as well as two other inputs, which are the grid input and then the solar input.